Okay, this will be our solutions video for section 3.3. Section 3.3 is a continuation of our journey on how to find derivatives. And in section 3.3, we were taught that the derivative of sine equals cosine. We were taught that the derivative of cosine is negative sine x. We were taught that the derivative of tangent is secant squared x. We were taught the derivative of cosecant x is negative cosecant x cotangent x. We were taught the derivative of secant x is secant x tangent x. And finally, we were taught that the derivative of cotangent x is negative cosecant squared x. These were the new ideas presented in section 3.3. So in our homework, they're going to have us do derivative problems, and we're going to incorporate now into these problems our derivatives of trig functions, which means when we start simplifying our solutions, because we always want to provide our solution in the most, in the simplest form, when we start simplifying our solutions, we're probably going to bring back some trig identities from back in the past. So let's take a look. All right, we'll start with number 3, the very first problem in the homework. And it says f of x equals sine x plus 1/2 cotangent x. And they want us to find the derivative. It just says differentiate. So the derivative is going to be, well, we start with the derivative of sine, that equals cosine. So we put that there, plus 1/2. The derivative of cotangent is going to be minus cosecant squared x. So our final answer is going to be cosine x minus 1/2 cosecant squared x. And we don't have any identities that exist that would simplify that, so that's our answer. Now, if we skip down to number 10, okay, in number 10, they give us a quotient, y equals 1 plus sine x. We can't simplify that. Divided by x plus cosine x. We can't simplify that. So we're going to have to use our quotient rule. Now we have a very rigid rule, or a very rigid beginning to solving the quotient rule problem. We put our denominator here, and we square. We put our denominator here. All right, this is how we begin every quotient rule problem. Now we take the derivative of the numerator. The derivative of 1 is 0. The derivative of sine is cosine. So we're going to put that right there. Minus. Now we copy our numerator here. We take the derivative of our denominator. The derivative of x is 1. The derivative of cosine is minus sine. Now, we don't expand the denominator. We know that. We leave that alone. We are, however, going to expand the numerator, right? We're going to collect like terms, see if there's any trig identities. So cosine times x is going to be x cosine x. Cosine times cosine is cosine squared x. Over here, we have minus. This is the difference of two squares. We have 1 minus sine squared x. And now we have to bring out one of our identities from back in the day. We have an identity, right? A real famous, the Pythagorean identity. It's kind of our first identity in trigonometry, other than tangent is equal to sine over cosine and the reciprocal identities. We get sine squared x plus cosine squared x equals 1. But in a calculus class, a lot of times you will see this identity not presented in this form, but let's move the sign over here and see what we get. We get cosine squared x is equal to 1 minus sine squared x. See, 1 minus sine squared x. So let's don't forget our denominator, x plus cosine x squared. So what is this going to give us now? Well, when we substitute in cosine squared for 1 minus sine squared, we get x cosine x plus cosine squared x minus, from here, 1 minus sine squared is equal to cosine squared. And on the bottom, we have x plus cosine x quantity squared. Remember, we don't expand the denominator. Well, those cosine squareds cancel, and we're left with x cosine x divided by x plus cosine x squared. So to do number 10, we had to remember a trig identity, right? Trig identities are going to be necessary for us to be able to simplify our solutions. We have to remember our trig identities. All right, so that was number 10. If we look at a problem like number 13, right? 13. In problem 13, they're just torturing us. This is what's happening in problem 13. We have x e to the x cosecant x. Now, when you take a look at this, what you have to realize is that's 3 functions multiplied together. Now, we don't have a product rule for 3 functions. Right? They didn't present us with a product rule for 3 functions. So the only way we're going to be able to do this is we're going to have to group these 2 together and call it f. And then we're going to have to call this one g. Right? That's how we're going to have to work this out. So when we do the product rule, right, we're going to have those as our products. So we're going to get f prime equals, of course, that f and that f are not the same f. That one's pink, that one's orange. So what do? We write the derivative of the first term times the second plus the first term times the derivative of the second term. Okay, I wrote all the steps out. And why did I write the steps out? Because I want you to see that right here, this is the product rule. So they've put a product rule inside of our product rule. Yes, that's exactly what they did. And this is how we work out 3 functions multiplied together. Is the only way we can do it. So now to solve this problem, we're going to take the derivative of x e to the x. So we'll just apply the product rule. I'm not going to write out the steps here. The derivative of x, that's my first term, right? That's my f, that's my g, so many f's and g's, but those are pink, that's orange, this is purple, not the same ones. So the derivative of x is 1. I write e to the x plus, I'm still working on the product rule here. I leave the first term there. I take the derivative of e to the x. That's e to the x. Now that gets multiplied by cosecant, right? That's how we're working this out. Plus, so we did the product rule times cosecant. Over here, we have this. We have just x e to the x. The derivative of cosecant is negative cosecant cotangent. Okay, so they're just trying to intimidate us with a whole bunch of functions. And if we just take our time, move through the problem step by step by step, we can overcome these kind of hurdles. So now we have cosecant times this
That's going to be cosecant x e to the x, right? We're doing the distributive property here, plus x e to the x cosecant x. And here we get minus x e to the x cosecant x cotangent x.
Now, what can we factor out? There's a cosecant here, there's a cosecant here, there's a cosecant here. We can factor those out. There's an e to the x, there's an e to the x, there's an e to the x. We can factor those out. So we can take out our common factors. So we get e to the x cosecant x. Here, that leaves us a 1. Here, that leaves us x. And over here, that leaves us minus x cotangent of x. So taking derivatives step by step, you got to do each iteration correctly, step by step, right? Step by step. You can't just do the whole thing at one time. It doesn't work like that. All right, so that was number 13. I'm not going to work out problems 15, 16, 17, and 18 because I did those in class, right? I did those in class. So, or I did problems like them in class. So what about problem 20? Problem 20 just says find the equation of the tangent line, right? We've done a whole bunch of those. So let's take a look at problem 20. Problem 20 is our friend the equation of the tangent line. We get y equals e to the x cosine x. And the point we're dealing with is 0, 1. So right now, we know the equation of our tangent line is y minus 1 equals our slope, right? Y prime times x minus 0. Our job is to find that. It's the product rule. So the derivative is going to be the derivative of e to the x. Okay, that's e to the x. Times the second function, right? That's the product rule. Plus the first function times the derivative of cosine, which is negative sine. Now we have to evaluate this at x equals 0. E to the 0, we'll just write it all out. E to the 0, cosine of 0, plus e to the 0, negative sine of 0. Okay, e to the 0 is 1. Cosine of 0 is 1, right? The graph of cosine starts here and goes like this. Cosine of 0 is 1. So this is going to be 1 times 1 plus 1 e to the 0 times sine. Sine looks like this. So sine of 0 is 0. So that's 1 times 1 is 1 plus 0. We get 1. So our equation of our tangent line is y minus 1 equals 1 times x minus 0. Okay. So that's problem number 20. All right. So what comes next, right, that we can work on here? Well, let's try something like, let's try 27, right? 27. 27 says, we have a function. Not the first time that's happened during one of our recordings.
So 27 says you have a function h of theta, and that function is equal to theta sine theta. And they want us to find both the first and the second derivative. All right, we did one of these in section 3.2. So the way we find the second derivative is we find the first derivative. All right, that's our first step. So this is going to be my f, this is going to be my g. The derivative of theta, theta is our variable, so the derivative of theta is going to be 1. So I write down sine plus theta. The derivative of sine is cosine. So my first derivative is 1 times sine. That's just sine. Plus theta cosine of theta. That's my first derivative. How do I find my second derivative? Well, I take the derivative of that. The derivative of sine is cosine. There's no product rule or anything there. It's just sine. Plus, now we have a product rule, right? So we've done this before. This is going to be my f. This is going to be my g. I mean, it's the same as this, except instead of sine, we have cosine. The derivative of theta is 1. I copy cosine plus theta. The derivative of cosine is negative sine. So I have cosine plus cosine. That's 2 of those. Minus, right, theta sine theta. There's my second derivative. What about 32? All right, 32. We can squeeze 32 down here, I think. 32 says, for what values of x does the graph have a horizontal tangent? So f of x is equal to e to the x cosine x. Now you and I, we have to translate it. Horizontal tangent. Horizontal tangent means slope equals 0, i.e. they're asking us, when does f prime of x equal 0, right? That's our question. So to find that, we first have to find the derivative. Product rule, right? That's going to be the derivative of e to the x is e to the x. So that's my f, that's my g. So I copy my g plus, right? And what's left? Well, I leave f alone. That's e to the x. I take the derivative of cosine. That's going to be minus sine. And if I factor this, I have e to the x. I have cosine x, because e to the x is a common factor, minus sine x. Now, we've graphed e to the x in class. Graph of e to the x goes like this. It never equals 0, right? Because that's what we're trying to solve. We're trying to solve, when does this equal 0? And we said in algebra that a times b equals 0 when a equals 0 or b equals 0. Well, this function, one of my factors, is never 0. So we're left solving cosine x minus sine x equals 0, or we're left solving cosine x equals sine x. Okay, there's a lot of ways for us to solve this, right? None of them involve us factoring and setting things equal to 0, though. We have to think about, when is cosine equal to sine? The easiest way, I think, to visualize this is go back to our friend the unit circle, right? If we go back to the unit circle, what did we say on the unit circle? We said on the unit circle, x equals cosine of theta. And we said y equals sine of theta. That's what we said, where theta is the central angle. That's what we said. So what we're being asked here, in essence, is, when does cosine equal sine? When do these equal each other? I.e., we're being asked, when do these equal each other?
when does x equal y? Now we know when x equals y. In algebra, they taught us this line is y equals x. So that happens here, and it happens here. It happens in the first quadrant. Why? Well, because all the functions are positive there. So sine is positive and cosine is positive, so they can equal each other. It happens in the third quadrant, because in the third quadrant, tangent is positive, which means both sine and cosine are negative. It can't happen over here. Over here, cosine's positive, but sine is negative. They can't be equal. It can't happen up here. For the same idea, sine is positive and cosine is negative. So we need to know what those angles are. Now, we know that's a 45-degree line. We know this is pi over 2 here. So we know this angle right here is pi over 4. And this angle right here, right? If we're going in over 4s, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, this angle right here is 5 pi over 4. So we need to be able to write this down, right? They don't want to know when does it happen in one rotation, because that's what we've done. We said, well, if you start at 0 and you circle around and you go all the way to 2 pi, you're going to have this happen twice. You're going to have it happen at pi over 4 and 5 pi over 4. So if we were going to do that, we would say, well, x equals pi over 4 or x equals 5 pi over 4. But unfortunately, that's not the only answers, because who said we could only go around the circle once? If we go around the circle again, right? If we go around the circle again, we go pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Well, now we need another one. We got 9 pi over 4. But what about 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4? So how do we write our answers? Well, we could think about the fact that all the way around the circle is 8 pi over 4. Right? Now that's 2 pi, right? So we could say it's going to be x is going to equal pi over 4 plus 2. Now, if we go around the circle once, it's going to be 2 pi. If we go around the circle twice, it's going to be 2 pi's. If we go around the circle 3 times, it's going to be 3 2 pi's. So we're going to put a constant in here, k, and write it like this. And we're going to say, well, it's some multiple k. K is an integer. It's some multiple of pi over 4. Or x is going to be 5 pi over 4 plus 2k pi. Now, before we get all excited about our solution, think, oh, okay, I got it. I add 2k pi because I could go around 2 times or 3 times or 4 times or 1 time. What happens if we go backwards? Right? Because we have to tell the reader what k is. Is k positive? Is k 0? If k is 0, we get pi over 4. Done. If k is 0, we get 5 pi over 4. Done. If k is 1, right? If k is 1, we already saw what happens there. We get 9 pi over 4 and 13 pi over 4. Done, done. If k is 2, etc., done. What happens if k is negative 1? Because couldn't we go this direction around the circle? There's no rule that says we can go that direction. That would be negative 3 pi over 4. That needs to be a possible answer. Because that's clearly an answer to our problem. Well, what happens if k is negative 1? Right? If k is negative 1, let's take a look at this piece right here. What happens if k is negative 1? We would have 5 pi over 4 plus 2 times negative 1 pi. That would be 5 pi over 4 minus 2 pi. That's 5 pi over 4 minus 8 pi over 4. Negative 3 pi over 4. So what we're going to say is we're going to say where k is any integer, not the positives or negatives. All right, so problem 32, because they didn't ask us to do it just between 0 and 2 pi, problem 32 brings this little, periodic argument into play. So let's take a look at another one. So that was 32. What about something like 39? Problems like this usually drive students crazy. They want us to find d99 over dx99 of sine x. They want us to find the 99th derivative of sine. Now, they don't expect us to do the derivative 99 times. They expect us to start with, okay, my function is sine. The derivative of sine, first derivative, is cosine. The second derivative is the derivative of cosine, negative sine. The third derivative is the derivative of negative sine, negative cosine. The fourth derivative is the derivative of negative cosine. So we have a negative. The derivative of cosine is another negative. And you know a funny thing? Right back where we started. Now we could write the fifth derivative, but I think the pattern is pretty much established. The fifth derivative is the derivative of sine cosine. And here we go again. So we have to ask ourselves, which one of these would be the 99th derivative? Well, the 99th derivative is a multiple of 3. So it's going to be the same as the third derivative. So the answer here is going to be negative cosine. Okay. Now, problems 43, 44, and 46 I addressed during the lecture. So hopefully you can go back and look at the examples that I did during the lecture and find the answers to, or determine the answers to 43, 44, and 46. All right, so that completes our video on section 3.1.